All right, let's jump right into this explainer. If you're watching this, you probably rely pretty heavily on your smartphone, and you know exactly how frustrating it is when it just can't keep up. Today, we're doing a complete deep dive into device speed and data hygiene. We're going to move step by step, starting with the surface level, quick fixes you can tap right on your screen, all the way down to the deep, hidden realities of back-end developer optimizations and digital forensics. We are absolutely unpacking how your phone manages data and performance from top to bottom.
So, you know the feeling, right? You drop serious cash on a premium device, and a year later, it feels like it's completely dragging its feet. Why does your super powerful mini computer feel so sluggish over time? Well, to really understand this, we're going to use an iceberg model to troubleshoot the problem. Right above the water, you've got the simple settings and caches that you can easily control. Just below the surface is the hidden factory bloatware that's secretly dragging your system down. And then way down in the deep water is the highly complex code developers are writing and the actual physical flash memory of the device itself. Here is our agenda for today. First, quick fixes for everyone, things you can easily tweak right now. Then, advanced Android debloating, completely without a PC. Third, how developers optimize performance in the 2026 arms race. And finally, the factory reset reality. By the end of this explainer, I promise you're going to look at your smartphone in a completely different way.
Part 1. Quick fixes for everyone. These are your basic, consumer-level adjustments.
Okay, before we get into the heavy developer tools, we've got to rule out the usual suspects. A sluggish phone is very often just struggling with weak network signals, completely full caches, or too many background apps hoarding all your RAM. Honestly, something as simple as pulling down your menu, turning airplane mode on, and then right back off can force your phone to drop a poor connection and immediately reconnect to a closer, stronger cell tower. It's a lifesaver.
Now, let's walk through a super effective, quick fix clearing your app cache. You just want to pop open your Settings app, scroll down and navigate to Apps. Find the specific one that's lagging, tap on Storage, and hit Clear Cache. This is awesome because it frees up storage space by dumping temporary files, but it doesn't delete your actual login data or your personal files. If you want a much deeper clean, you can actually wipe the entire system cache partition. Think of this as a massive digital decluttering session for your entire operating system. You just power off the device, press and hold volume up plus the side button, and release them when the Android logo pops up to enter recovery mode. From there, use your volume buttons to scroll down, select Wipe Cache Partition, and reboot. It clears out old OS temporary files that cause that annoying system-wide stuttering. Here's a crucial one that a lot of people miss: your network settings. Both Android and iOS have these data saver or low data mode options. Now, while these are absolutely great for keeping your mobile bill in check if you have strict data caps, having them turned on actively throttles your speed. Disabling these modes is literally an instant software tweak to maximize your 4G LTE or 5G speeds, letting your phone pull data as fast as the network physically allows. Moving on to part 2, advanced Android debloating, specifically doing a PC-less cleanup. All right, time to plunge a bit deeper into advanced power user tweaks. What do you do about that annoying factory bloatware that the manufacturer absolutely refuses to let you uninstall? Well, first, we have to unlock the developer options. Go back into Settings, tap About Phone, locate your build number, and just tap that number repeatedly until a little prompt pops up saying you are now a developer. Boom, you've just unlocked advanced system controls. Next up, inside those newly unlocked developer options, we need to set up wireless debugging. Turn on USB debugging first, then enable wireless debugging. Now, a strict requirement here is that you absolutely must be connected to a Wi-Fi network. Even a friend's mobile hotspot will do the trick. Once you're connected, tap Pair Device with Pairing Code and make sure you write down the 6-digit code it gives you. Now, here is where it gets really cool. The tool we use next is an app called Shizuku. Normally, if you want to deep clean core system apps, you need an ADB connection using a physical cable hooked up to a PC. But Shizuku cleverly leverages that 6-digit wireless pairing code to emulate a PC connection right there on your smartphone screen. It runs the ADB service entirely locally, giving you safe, elevated permissions without ever needing to root your device. Once you've got Shizuku running in the background, you open up an app called Kanta. Kanta visually maps out every single app on your system. You just search for that carrier bloatware, tap it, and hit the delete button. But listen up, here is a stern professional tech support warning. Kanta sees everything. Never ever uninstall apps flagged as unsafe or core system files, or you risk completely collapsing your entire operating system. Seriously, just stick to the unused bloatware. Section 3. How developers optimize performance.
Welcome to the 2026 arms race. Let's dive way down into the dark waters of back-end engineering. You've cleaned your cache, you've debloated your system, but how are app developers fighting a multi-dimensional war against latency on their end? Well, 500 milliseconds. Literally, half a second. In 2026, this is the strict new standard for a metric called time to interactive. Market leaders are frantically racing to hit the sub-500 millisecond boundary because user expectations are now set by instantaneous AI responses. If an app takes 2 seconds to load today, it's basically considered disastrously slow. This kind of speed is officially tracked using something called Core Web Vitals. These are the exact metrics that AI-driven search engines use to rank websites. You've got LCP, which measures how fast the main content loads. The target there is under 2.5 seconds. Then INP measures responsiveness to your tabs, needing to be under a blazing fast 200 milliseconds. And CLS ensures the layout doesn't unexpectedly jump around or shift while it's loading. There's actually been a massive paradigm shift lately, moving away from a metric called first input delay over to interaction to next paint, or INP. Why does this matter to you? Because an app or website used to pass the test if just your very first tap was fast. Now, INP evaluates every single tap, swipe, and click throughout your entire visit. The experience has to remain buttery smooth continuously, which forces developers to break up heavy background tasks so they don't freeze up your screen. And here is where it gets super smart. Modern apps don't just react to your phone lagging anymore, they actively predict it, using adaptive resource throttling. This is an on-device machine learning model that constantly monitors your battery temperature, your available RAM, and your network signal. If it notices you're on an older device with 30% battery left, the app's AI predictively lowers video quality and prunes caches before your phone has a chance to crash or stutter. Plus, developers are completely ditching old network protocols. By migrating to a tech called Web Transport, which uses unidirectional streams instead of waiting around for synchronous server replies, developers are reducing perceived latency by a massive 27%. Essentially, the app doesn't wait in a single straight line to load images and text. It streams them all in parallel, making your phone feel drastically faster. And finally, Section 4, the factory reset reality, forensic truths. We have officially hit the bedrock of this explainer. You've optimized everything, it's running great, but what happens when you're done with the phone and you perform a factory reset? There is a vast, crucial difference between logical deletion and physical erasure. When you do a standard factory reset, the phone usually just performs a logical deletion. It deletes the directory pointers, making the data invisible to you, but leaving the actual photos and messages sitting right there in the flash memory. Physical erasure, where blocks are completely overwritten with random data, takes way longer and is rarely what a standard consumer reset actually does. Because a standard wipe is mostly just logical deletion, digital forensic tools can extract a frankly shocking amount of data from a supposedly wiped device. What actually survives? Huge chunks of unallocated storage space full of your old files waiting to be overwritten. System partition logs that detail your historical app activity. Fragments of multimedia like old photos and videos. And if the encryption keys weren't handled perfectly by the OS, even encrypted data fragments can be pulled and reconstructed. The big takeaway here, consumer factory resets are built for the secondary market. They prioritize usability, speed, and quick device reinitialization so the phone can be easily resold or handed down to a family member. They are absolutely not designed for forensic-grade data destruction or absolute privacy. A reset removes your easy access, sure, but not necessarily your digital traces. Which wraps up our explainer, but it leaves us with a pretty profound, maybe even slightly unsettling realization. You've optimized your speed, you've used Shizuku to clear your bloatware, and you're enjoying lightning-fast web transferred apps. But if you wipe and sell your phone tomorrow, who really holds your data? It's definitely something to think about the next time you confidently tap Erase All. Thanks for exploring this with me today, and I highly encourage you to look deeper into how your specific model handles hardware encryption before you hand it off to a stranger.